Can you see me or hear me? Okay. Okay. No, I can't. Oops.
Can you hear me now?
Okay, great. Yeah. Can you hear me?
Yeah.
Okay, great, excellent. And good to see you. And my name is Yao. And by the way, what's your name, please?
My name is Vivek.
Vivek. Hey, nice to meet you. Welcome to
Nice to
join
meet you.
this session.
Yeah.
Okay. I think this is my session. Let me get started.
Yeah,
So and then
this is your session. That's right.
yeah, and then we will
Uh,
swap. Hmm.
yeah. So, do you want me to go over the question for you, or do you want to read it?
Let me take a look at it to see what's asking. And then
Mhm.
when I have a question, I will come back to you.
Okay.
Um, okay, let me see. Write a function flip that reverse the order of the first k element in the array. Okay, and then write a function. So I need to write two functions, right?
You need to write two functions. Yes.
Okay, and okay, write a function that's short and return the input array. You are allowed to use only the function flip you wrote in the first step in order to make the change in the array. Okay. Okay. So okay, flip. Basically, what it does reverse the order of the first k element. Okay. Minimize the time and space complexity. It's called pancake sort because it resembles sorting pancakes on the. Okay. Okay. I don't need this information. I don't think. Okay. And also there's some constraint. Okay. Uh. Okay. Cool. And let me think about here. So essentially, I need to write two functions, as you mentioned. So another one is it's called flip and k, and what it does is to reverse the order of the first k elements. Okay, okay. Uh, let me try to understand this. So I basically keep reversing the element of the first k element, right? And then until a point where the thing is sorted.
Right.
Let me think about how this works. But in but in what? But how can I keep reversing something and then keep until it becomes sorted though? Let me think. Uh, Reverse something. This is 15432. There's a link in here, so you go to Wikipedia. Okay. Yeah, I kind of need some direction. Can you help me
Oh,
out
sure.
here?
Yeah. So, did you understand the first one? Flip array comma k.
Yes. So
So you
basically
understood
reversing
that
the
one.
first, yeah, basically
Correct.
reversing the first k orders.
Yeah. Now the pancake sort is, yeah, you're passed an unsorted array and you need to return an array that is sorted. Uh, and the only thing that you can do here is you can use the flip function and nothing else. So, uh, so say 15432, right? So let's say in every pass you are able to do some flips and get some element in its correct place. Is it possible to do that? Like think of it that way. So 15432, maybe in the next pass, uh, you have one element in the correct position, and then you can ignore that element and then sort the rest of the array.
Oh, okay. So for each pass, I will have one more element that is in the correct position, right? Is that what
Right.
you're saying?
Yeah.
Okay.
And to get the element in the current position, you can use the flip.
Okay. Okay. Well, that's okay. That's better than what I where I was before. A few minutes ago. Okay. So if that's the case,
I mean,
in
again, to make things clear, flip is the only function that you can use to make changes in the array. So if you want to make changes, like the only thing that you could do is flip. Uh, that's the only constraint. But think about how, like, maybe walk through an example, or yeah, I think the key is to figure out, like, assuming you do this flip multiple times, right? Or take one pass. So the goal of that one pass is to get one element in that correct position. Now, the one way to think about is what should be that element, right?
yeah, it
Like
will
what?
be. Okay. Yeah. Go on. Go on.
Yeah. So I'll give you a few minutes to think, like, and if yeah, if you need more hints, I can give more hints.
Okay. Well, based on the example I'm seeing over here, so it looks like this. So, and also based on the hint that you just told me, I need to work on one element for each of the paths, right? So I'm thinking like work on the lowest element for the first time. So it will be the first guy over here, and that so happened that is in the correct position.
Hmm.
So I'm good with that. So the next one I'm going to work on is the two. So what we're going to do is to so the one we can put it on the side already, and I'll put it easier to see. And then in here, the second one will be, and then I call the flip function to reverse the order. So it's going to be 2, 3, 4, and
The
5.
problem is the flip uh, reverses the order of the first k elements, right? So if you're doing a flip, so you're somewhere on the right track. So let's say you choose one, and now you need to do a flip of two. It will move one from that current position because it's going to do a reverse of the whole array. So the
Oh, okay.
function, yeah, it reverses the order of the first k elements of the array. So you need to. Uh, so what does this imply, right? Like if the correct position of that element should not be in the first k elements, because we want to do a flip, that first position is going to get undone. So
Oh,
it
okay.
needs to be somewhere else.
Okay. So if that, yeah, I understand what you're saying. So because you keep scrambling the whole thing, that's why. I mean, the first K element gets scrambling.
Yeah, the first
That's
k gets
why.
scrambled, but that also implies that there is some other elements that do not get scrambled.
Yeah. So that will be the because he said this will be the first K. So the and the last K plus. I mean, from the K plus one to the end, those one will not be touched then.
Correct.
So
Yeah,
maybe I can work on it backward and work on it from the end. If that's
correct.
the case, I probably the first pass I need to work on the last element, which is I mean the biggest element. In this case, it'll be five. It'll be five. Um,
Right.
so five and keep reversing the order. So make sure to understand this. So let's say if I call the reversing order or the whole thing will become like a two 3, 4, 5, and 1. Right? So if I reverse the whole thing, it becomes something like this.
Yeah, obviously um if you directly reverse the whole thing, it doesn't do anything, right? It's just
Yeah, yeah,
another one unsorted array. It's not getting you to that goal that you want.
yeah. It's not getting me anywhere. Exactly. It's just I'm still staying in square one, unfortunately. So
Right.
the first thing that I'm going to do is to so I was thinking about how can I keep reversing the array until a point where the 5 will be at the end.
Right.
So if I need to get the 5 at the end, I need to get the 5 at the front first. If that's the case, maybe okay, maybe this is what I'm gonna do. I'm gonna get the 5 to like here, which I can do, right? And then
Yeah.
after that, I can reverse the whole thing, and it becomes like 2, 3, 4, 1, and 5. So the 5 will be in the correct position. So that's my first step. And second step will be the 4. And the 4 maybe, oh, okay, I mean, I kind of see it now. So maybe the 4, I can reverse the, so maybe in here, the k is equal to, I make it aligned so we can see everything in the same column. So in here, the k is equal to first two elements. So k equal to 2. And this one is k equal to the whole length. And then because yk is equal to 2 because 5 was at the, so 5 at the 2, I mean at the 1 spot, so basically the position of 2. Pause 2. Okay, so and then in the next number I'm going to work on is the 4. And then maybe what I can do is to have the 4, 3, 2, and then 1 and 5. So in this case, k is equal to 3 because it's the first 3 elements. And then after that, it will be reverse the whole thing minus 1. So because basically the last element I'm done. Bless you. So it's 1 gonna be 2 and 3 and 4 and 5. So in this case, it's gonna be k is equal to the length of minus 1. In this case, it so happens is done. If it was not done, I'm gonna work on the number of 3 and then put it back to the front, and then yeah, yeah. So I'm not sure if I'm on the right track though.
Yeah. You're on the right track.
But the thing is, I have to keep finding the biggest element in the specific array.
Yeah, you can find the biggest element, right?
Yeah, maybe I can maybe this is only like a 3 passes. I'm gonna try a different example to make sure.
So yeah, yeah,
Yeah, yeah. Go ahead. You have something to say?
yeah. Go ahead.
Yeah.
I
Okay.
mean, you
Maybe I
can
can
try
try.
a shorter array
Yeah,
and
yeah.
see if it
Exactly.
works.
Exactly. I'm gonna try like a 4, and 9, and 3 and 1. How's that? So I'm gonna try maybe, yeah, 3 and maybe 1 and 6. Yeah. Hopefully that's pretty bad in the ordering. So and first thing I'm gonna try is the biggest number, and here is the max. In here is gonna be the max, the whole thing of whole thing, max of the whole thing, which is the 9. So I'm gonna first, which is at the index of 1. So first I'm gonna revert, and so I'm gonna make k equal to 2. So in that case, after I flip it, I'm gonna become 9, 4, 1, and 6. And then next one is gonna be k equal to length. If I do that, what I'm gonna get is gonna be a 6, 1, 4, 9. So the 9 is in the correct position at this point. So and then the next string is going to be max of the the everything before the 9. So it's going to be max equal to 6, which is the index of 1, and of 0. So in this case, is k equal to 1. In this case, k equal to 1 is going to be what was it? So yeah, so k equal to 1. So first one element. So it's gonna be, yeah. So 1 is, so that's correctly positioned. So it's 1. Yeah, it's gonna be like that. And then I have to like and then k is equal to len minus 1. And then if I do that, it's gonna be looking like 4, 1, 6, and 9. Yeah, so the 6 is correctly positioned. So the next one I'm going to work on will be the max is equal to the 4, which is positioned at of 0. So the k is equal to 1. If I do that, it's going to be yeah. So we 4, 1, 6, 9. Okay, yeah, that looks like it's working. And then 1, 4, 6, 9, because in this case k equal to length minus 2. Okay, I think it looks like working. I think so. Looks like the flip function. The flip function will be resigned with inside the pancake sort. So it looks like something like if I'm given a array and the k, and what I need to return looks like something like this is just some pseudocode. Return reverse the order of the first k element. It'll be r equal to the first k element will be looks like something like this, right? And then hold on. Yeah, this is not entirely true though. I have to truncate into 2 pieces. Yeah, so it'll be like a 2 pieces, and then the first piece has k, and then I will reverse the first piece and then concatenate the second piece, which is not touched.
Yeah.
Yeah. So yeah, so this is something that I was thinking, and the second piece will be the pancake sort. So as we discussed, so the pancake sort will be I need to find the maximum, the biggest number, and then the second biggest number. Well, it will be so it's going to be the max. So the first one is the max of the array. So the next number I'm looking at is the max of the array except the last one. Except the last one is going to be something like this, and then accept and then keep going, and also at the same time, while I'm looking for the max, I'm looking for the index of the max as well, because I need that for the case index.
Right.
Yeah. Do you think this is a maybe a workable solution?
Yeah. So you can start coding.
Okay, good. Thank you for the confirmation. So I'm thinking about the time and space complexity. Maybe I can think about that while I'm coding then.
Sure. Yeah.
So first I have, as we discussed, I have a this nested function, which is the flip and the array. I'm gonna call it a array, and I have the first piece, which is I'm gonna call it k piece, and it's gonna be equal to the a array, which is the first k element, and then the maybe the second piece, I'm gonna call it the rest. The rest equal to the rest. Basically is in the k plus 1 and then to the end. And then what I'm going to return is going to be reverse of the k piece. Looks like something like that, and then concatenate with the rest. So So that's the flip function. So and then now I'm gonna work on the main part of the pancake sort. And let me think. So yeah, so the first thing is we are basically narrowing down one element at a time. So um, I have so let me think. So um, yeah, so for maybe uh, index in the length of the array, maybe let me think. Uh, let me think. So I yeah. So what I've been thinking was the first pass, the first max will be equal to the max of the whole thing, and then the second max is the max of the whole thing, but the last element. So how can we do that? Will be and in this case, to generalize the
Sorry,
idea will
why do
be
you need second max? So in your walkthrough between lines 15 to 31, you're only finding in each pass you are finding just the max, right? You're
well,
finding max for a subset of the array.
yeah, exactly. So the first subset of the array will be the whole thing. The second
Hmm.
subset will be everything but the last element.
Yeah, so that's yeah. So every pass you will have a new max. So there will
Yeah,
be a third max, fourth max. It
yeah.
depends on
So
each
yeah, I'm
pass.
thinking about thinking about how to generalize the idea to make sure that um, the formula gonna apply to I'm finding all the marks of the subarray. Maybe I can call it something like current marks, and the index I'm thinking of. So the first one is 0, -1, all the way. Okay, let me think. So how can we do that? So obviously we have the for loop for index in range of from 0 all the way to the end of the thing is gonna be the length of the array. Um, yeah, so it keep increasing. Um, so there is 0, 0 -1, -2, and -3. -3. Okay, the length is 4. Okay, yeah, that works. Okay, yeah, so this is gonna work. So it's gonna be minus the index. Yeah, so the current max looks like something like that. And at the same time, I need to get the index of the current max. Maybe, okay, maybe what I can do is to get, let me think, maybe current max index equal to array dot index of the current max. And by doing that, I can get the index of the thing. So let me think. So max dot. So I'm looking at line 25. So the max of the whole thing is 9. The index of it is 1. So okay, now I'm gonna work on the k. K is the current max of index plus 1 because the first two elements. Yeah, and then I'm gonna call the flip function, um, which yeah, so which is looks like something like this. So the array equal to the flip function. Oops, we go back here. Flip function the k. Yeah, and then here. Okay, I think yeah. So this is yeah. So I'm on line 27. So flip the first two elements. So the largest element at the back. And now what I'm going to do is to flip the whole thing all together. So it's going to be array equal to the flip function, and then oops. So this one is going to be something looks like that. Oops, indentation. Also spacing, make it more readable. Okay, so it's something like this. Also, I'm following the convention of a camel case, so I need to make myself more consistent across the lines. So, and then flip it for the first k element, and then the next one is going to be flip it to the length of the array. Maybe I can sort that variable somewhere. So, length array equals to the length of the array, and the first one is going to be the length of the array minus the index, because the thing is yeah, the thing is the index started with 0 and then increase by 1 each time. Yeah, that I think that may be the way to do. Let me think. So I think, and then the index increased by 1. Yeah, I think maybe working if we follow the code. Let me do a dry run of the code. But before doing that, also there's a question that is asked you here. Analyze the time and space complexity in the solution. So
I
the
think we
time.
can get to the time complexity later, like once we prove the correctness, just for the sake of time.
Okay, yeah, that's fair. So let's walk through this example. So 15432. So the first thing is I'm the index of 0. Maybe I can have it over here. So I first have the index equal to 0, and current max equal to the max of the whole thing. So this is this guy over here. Max the whole thing. Oops, max of the whole thing. Oops, which is the 5. Okay, also the index, the current max index is equal to find the index of it, which is 1. And then the k is equal to 2. And then now what we're going to do is to flip the whole thing. Flip the first two elements, in this case, inside is the 2. So what we're going to get is going to be 5, 1, 4, 3, 2. And then now what we're going to do is to reverse the whole thing, which is the 2, 3, 4, 1, 5. So the 5 is at the back. And then now next one is the current max. Current max is equal to the max of the one but the last one. And then what we're gonna get is the 4. And then the index of it is equal to 0, 1, 2, which is going to be 2, and in this case is k is equal to index plus 1 is 3. So let's run the flip of it. So gonna run the flip the whole thing, the first 3 elements. What we're gonna get is going to be 4, 3, 2, yeah, 4, 2, 4, 3, 2, 1, and 5. And then now what we're gonna do is to flip everything but the last one, which is the length of the array, minus the index that we have right now. The index what we have right now is actually okay. Yeah, there's a bug in here. So minus the index, I think. Hold on, is that not right? So let me think. It's okay. I think it's fine. Yeah, it should be okay. I think so. Minus 1. So what we're gonna get is to 1, 2, 3, 4, and 5. And then I will keep doing it until the end. So So now the next one is gonna be the current max. It will be the four, the three. So the current max index is equal to 0, 1. I think I'm running out of time, but it looks like it's working. Uh,
Yeah, I
or do
think
you?
uh, just few call outs. On line 13, you have k equal to correct current max index plus 1, right?
Yeah.
So what happens if current max index is the last index, which is n minus 1, length of array minus 1? Then k will be length of array and would flip work as you expect it to be.
Sorry, say that again. What happens if the
So
index
what
is last
happens
one?
is k. So in this example, you have a five element array, and let's assume the max element is already at the fifth position,
Okay.
and so k would become five, right? Current max index would be four in a five element array,
Yeah.
and k would be five. Now, if you pass flip of array comma five, will that function work as you expect it to?
Let me dive into the function. So in this case, it will be array of 0 to 5, and then the next one is okay. So I see what you're saying. So it's gonna be here. It will be 6.
Right.
Okay. 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 So I think what we're gonna do is to mm, the first 5 elements. Hold on. So yeah. So it's gonna be um. So let me think. So the fifth element, uh, 0, 1, 2, 3, 4, and 5. And yeah, so let me look at the index. So 0, 1, 2, 3, 4. Okay, if we look at the last element, which is the 4, um, talking about something looks like this. So if that's the case, I need to. Okay, maybe I don't need the plus one over here.
Yeah, think
Yeah, I don't.
sounds right. The other issue is on line 6 and 7. Um, do you see like the
Oh,
ending?
maybe yeah. Here, maybe like this.
Correct.
Let me think again. So if I given an index of 5, so yeah, it should be okay. Start with 5. If that's the case, okay. Um, so I still need to plus one over here then.
Yeah, but you just need to
Yeah, here.
handle
Yeah,
that
that would.
case where it's just the splicing and the join operation. The rest could be the way it is written now. The rest could, in case the k is the last element, the rest can result in index out of bounds, right?
Yeah.
So you need to check. So
Sorry. What what
in
what 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 did you say again?
no, on line 7, if k is the last element of the array, then line 7 could result in index out of bounds, right? Now hold on.
If the
It will
case
just
is the
return an empty. Okay.
yeah
Okay. Yeah. Then in that case, it should be fine. Okay. Yeah. Sounds good.
yeah, but I
You
do
want?
not like I don't like this one in particular because I'm basically creating a copy of the array. One optimization if I can just directly do it in place and do a swap,
Yeah.
and then
That
that
could
can
work.
save some space. For well from
Do you want
top
to
well
run the program and see?
I'm okay actually. Maybe I'm not sure there's a bug, but yeah, maybe I can run it after this section. I don't want to waste
Okay.
your time now if there was some bug coming up. But I do want to maybe have a 1 more minute to discuss the time and space complexity.
Yeah. Yeah.
So,
Good.
and for time complexities, it look like n square. Uh, yeah, it looks like it's n square because I have the foldable here, and this is gonna be big O n, and also this one is gonna be big O n as well. So it's gonna be big n, and it's gonna be n square. For space complexity, well, now it's B of n, but we can optimize it to be B01 if we have the flip do it in place. We keep swapping the first k elements, and we can do that if there's some optimization. And yeah, what do you think?
Yeah. I think that works.
Okay, and do you think my thinking on the time complexity makes sense?
Yeah. Yeah. It is correct.
Okay, okay. If you are
The
you are
only
satisfied.
one call out is you may get the test working. I think like on line 12, you're using array.index of current max. That will be an issue if you have multiple max or multiple duplicate elements, right? Would it?
Oh yes, oh, yeah, you're
Yeah.
right. I, in that case, okay. Yeah. Okay. I will think about that after this section. Yeah. You are. Yeah. Yeah. So this one is for me to think.
You just need to put array of dot, I mean colon minus index dot index of. I think then it would work.
Array of like -1 over
No,
here.
no. I
Oh.
mean, so whatever you're doing here,
Oh. Right. Just only look at that particular section.
yeah.
But hold on. But in this case, this subsection, if that has multiple number, is the same current
Yeah, it
max as
is.
well.
It's actually the same problem. Yeah.
Yeah.
So
I.
you should probably like compute max on your own and uh, return the index.
Yeah. This one was not the best one I was thinking of. I know that it's gonna be have some problem actually. Anyway, I'm glad that we get to this point though, within 30 minutes. But I don't want to take in time of your session. Let's swap it.
Sure,
Thank you so much for your interview.
no problem. Uh, do you want to go over the question for me?
Yeah, yeah, I can do that for you. So it looks pretty wordy, but we can dive straight into the example. So as the name says, it's the decrypt message. Basically, we want to basically, for example, the decrypted message is look like crime. I'm gonna put it on the IDE so you can see. So the message want to decrypt. This already decrypted. It's crime. So the ASCII code for crime for C is 99, 114 for R. So I'm gonna make it aligned so you can see them better. So the ASCII code for C is 99, ASCII code for R is 114, etc. And ASCII code for I is 105. So that's step one. So the step two is to add one. So for the first ASCII code is 99, add one is 100. And then the second one is 214, which is a 100 over here minus a plus a 114. and then the 319, it is the 214 plus the 105. Basically, like look like a running, it's a running cumulative.
Mm.
And then
Okay.
and then yeah, and then the third step is to yeah, bring
Sorry.
it back. Yeah, yeah, no worries. Bless you. So the number that we are at the step two, we bring it back to the ASCII the ASCII code for the normal alphabet. Because in normal alphabet, A it is 76. Let me check if that's 76 or not. Yeah, and no, A is a 97, and then all the way to maybe have this one for your reference. I'm just gonna help you. It does certainly gonna help. It helped me a lot. So A
Hmm.
is 97, B is 98, C is 99, and C is 123. So essentially, when we arrive at step two, we just bring it back to our ground, which is from 97 to 123. Just keep minusing the 26 until a point where we arrive to this ground, and then we have this ASCII code, and then convert it back to a characters, which in this case is D, N, O, T, and Q. So the task that we are given right now is we are given like a D, D, N, O, T, Q. How can we back translate the message back to the crime?
Okay.
Yeah,
Uh, okay. I didn't understand some portions of it, so let me go over it. So in step one is just the direct translation of the characters to ASCII code, right?
correct.
And step two, I'm assuming these are like different passes. So in second pass, you should add the one number one to the first character because
Yep,
there's no previous character. And
correct.
for every other character, you add the step one ASCII code plus the previous character's current value, whatever the step two value is. So it's 100. Okay, that I got it.
Yep,
Step
exactly.
three, I didn't understand how step three was reached.
Yeah, maybe I can give you an example. So, uh, for example, the first one is 100. So essentially, 100 is between 97 and 123,
Okay,
right? So we are good.
okay,
So and then let me pick another example. I think that may not be the well. In this case, all of them is in that range, so we are all good. But let me give you an counter example. Let's say if that number is, let's say, 124, okay, which is not in that range. So we are not good. So what we're
okay,
gonna do is the 124 minus the 26, and then we bring us back to the range which we are okay, which is 97 and 123.
okay. So you need to subtract minus 26 until it's back to the between minus, sorry, until it's within 123. Is that
Yeah,
correct?
yeah, yeah, yeah. Sorry. Let's walk through an example over here. I think um, I'm afraid I didn't make myself clear. So the second number is 214, right? In this
Mm-hmm.
case, we are no good. So
Yeah.
how can we bring it back to the range of the good range, which is 97 and 123? We keep minusing the 26 until we keep minusing until we are in that range. Minus
Okay.
26 or minus 26 one time, two times, or however many times we need.
Okay. Got it. Okay. Uh, so you keep subtracting minus 126. Is there an easier way, like instead of, okay, the first thing is instead of keeping on subtracting, uh, I'm thinking if you can, oh, sorry. Oops, what did I do?
Yeah,
Okay.
you can
Yeah.
imagine.
So you need to So this has to go within minus 123. So what is this? This is something like 171. Yeah, 71. Uh, 71 is how many 126 you require to get to cross 71 that you can divide, I guess. Yeah, maybe then seal of uh, okay, will this formula work? I'm thinking. so so let's take an example of 123. Now 123 is already in that range, so that's good. So 124, you have okay. So for 124, you need to subtract minus 26, right? Or should you subtract minus 1? I guess I didn't get that. So it should be minus 26.
Let me
So
do the
for
calculation. 124 minus 26 equal to 98. Yeah, that's
okay,
exactly what
so
you need.
okay,
Minus
okay, you
124.
have to do minus 126. So if you apply this formula, that would be minus 26 into um, seal of 120, 124 minus 123 is 1 divided by 26, so that would be 1. So minus 26 into 1. Okay, I think the formula should work. So I mean, so I know I'm not. Maybe that's something that we can think of it later. I don't think that's the core of the problem anyway. Okay,
Yeah,
I got it. So it's minus. You need to subtract minus 26 until it is in the range. Okay, so that's good. Now the core of the problem is that you have an encrypted range message and you need to go back to the decrypted range. I think
exactly.
that's the one. Okay. Mm, so you need to kind of reverse the steps that you have done.
Yes, exactly. Doing
Uh,
backward.
right. Okay. So from DNOTQ, you can get step three by just getting the uh, what is the ASCII value, right? So this is just the ASCII representation of the input.
Exactly. Exactly.
Uh, Now from this, what do you do? Hold on. Now how do you? Oh, okay. So um, now what do you know? Now if I'm thinking, how do you go to step through? You don't have that information on how much out of range it was. I mean, it could be 214. It could be 214 plus 26 as well. Uh, so how do you change. So 100 is pretty straightforward. It's the first thing, so that becomes 100.
Yep,
Now from
exactly.
110, it could be 214. Uh, but it could be something greater than 214 as well, right?
I think,
No, hold
hmm,
on. Hold on. Oh, okay. There is a sequence here. It's like it starts from 2, 3, 4, 5. Uh, okay.
okay.
So what if I keep adding 26 um, until it is between the range 200 to 300? Does that work? Uh, and that would be the number. No, hold on. So actually, I'm changing the example. So let's say if it's z, right? Solve the last value. So this would be this would be the decrypt. So step one would be 123, 120. Sorry, yeah, 123, right? And 123.
Yep,
And step through would be 124. Uh, and 124 plus 123 is what? 2,
two, 247.
247. And this would be 3, 6,
Yeah,
okay,
360.
370, 370 or something.
Was it three? Yeah, 370.
Okay. Mm,
Well, I want to give you some hint in here. It's not an easy problem, I must say. Um, and you certainly making a lot of good progress in here. You now in a you are in a place where you fully understand what we are doing. So a lot of people I ask this question, they got stuck exactly where you get stuck right now. Is how
mm.
do I um, go from step three back to step two, and then people try to aim the range that is should be okay in step two, and then do
Yeah,
the
the range
reverse.
is not going to. Yeah, I see that the range. I thought about the range, but the range is not going to work simply because the numbers are increasing, right? So it's 370 plus 123. That would be 493. Yeah, I don't know how the range. Like as the input keeps increasing, actually, will the range work? Okay, actually, go ahead.
Yeah. So let me give you some hint. I want to help you out here. So maybe maybe we can directly take the difference in the step three, and then you can see how what kind of so you can try it right now. So I can try for you. Okay. So I'm just simply taking the difference, and then you can observe what's going on. Okay. So the first difference will be 110 minus 100, which is 10. The next one is gonna 111 minus 110, which is 1, 5, and negative 3. Okay, I'm just purely taking difference. Okay, so what do we learn in here? And the message from learn from here, maybe it will be really helpful to for us to go to here.
Got
I'm
it.
gonna I'm gonna put it on pause and then give you some space to think about it now.
Mm. Okay, so that's the difference. think. Okay, let me repeat your hint. You said you calculated the difference between those two numbers,
Yep,
right? And figure out how that difference, from that difference, how I can get to step one.
exactly. And you don't need to worry about the first number. The first number is easy, right? The first number is really
Yeah,
easy.
yeah.
So don't think about the first number. You get it in like in a second or less than a second. But think about the rest. And now we have the difference. So what do we learn from here?
Hmm. Okay, one thing I see is the numbers. I mean, I don't know, like the numbers are increasing and decreasing.
Yeah.
I don't know if that. So the number after C looks to be okay. So the number after C is more. I mean, in value, in ASCII value. So after C, it says 10, right? So whatever that alphabet, it's more in ASCII value after C, and after 10, it's 1. So yeah, that's a pattern. But so like one hit, does the absolute value help? Like 10 as an absolute value. Do you think
Mm,
it helps in any way? Or is it
mm,
more of the directionality of the values? Like so if the value is ABC, right, the number would be increasing. I suppose it would be like
yeah.
either
Yeah.
same or it would be one, two, three, four.
Yeah, if the number was A, B, and C, it will be increasing. But in this case, it's not increasing. And I can tell you, absolute value may not be helpful in here.
Okay, so the absolute value does not really. The second hint is like, can you add something to that value and get the actual value?
Whoa, you are onto something. I think that might be worth trying. Yeah, yeah, you're
Okay,
on the
so
right track now.
you need to add something.
Yeah, let's try that. Let's try adding it and to see what we can get.
So this one, the actual difference between 99 and 114 is 15, but what you have here is 10.
Let, let's let's
Uh,
let's 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 try to add something to the 10 to see what we can get. Let's just experiment. Okay.
let's add something to 10. Uh, Hold on, okay. Hmm, Okay, so adding 10. Do Yeah, like are we trying to go to step two or step one?
You can go directly to step one. I
Okay.
can tell you.
Hmm.
Step two is confusing you.
Okay, so I think something I have to do with 26. I just haven't figured out.
Exactly, exactly. Yeah, keep thinking
This
along those lines.
26 has some link. Uh, So 26 minus 10. What does that give? 16 minus 1. 50.
Well, what about we don't minus, we add 26. I'm gonna show the example right here. In here. So if we add 26, right? What do we got? Like 36,
36, 27,
20, yeah, and
31,
then
and 23.
yeah, and 23. And does it mean anything? Probably not, right? It's not meaning anything to me. So what
Yeah,
about
it
if
doesn't
I
mean.
add? Yeah, what about if I add 26 again? What about do it again?
Okay.
If I keep doing it until it means something to me, and then if I
Until it
back
comes within the range. Oh, okay.
exactly, and then to see what's the message at that point.
Yeah, yeah, yeah. Okay, so let's take the 23 example, right? So 26 plus 26. You need to come within 97. So 97 minus. No, it doesn't work that way. Okay, so I think it's just better. So 23. Okay, I'm just taking 23 number. 23 plus 26. That, that is equal to 49. 49 plus 26 is 1575. 75 plus 26 is 101. Okay, that's nice. Okay,
There you go.
so that
I think
seems to be the code. So yeah, finding the difference and keep adding. So for the first character you need to do -1, and for the remaining characters you need to keep adding 26 until it reaches within the range of 97. I mean until it's about 97 basically, about or equal to 97. Uh,
exactly.
ah, yeah, until and then once you reach that, until as soon as the number reaches about 97, then get the converted back to the character.
There you go. Yeah, perfect. That's exactly what we're talking about here.
Cool. Maybe I can write some quick code.
Yeah, yeah. Let's do that. Yeah.
So you need to do for each character and word, right? So that is the input, the decrypted message, and I don't know how to get ASCII in this thing. ASCII of D equal to. I'll just assume that this function can return ASCII. Do you know how to get the
Oh,
ASCII in Python?
yeah. It's gonna be ORD.
Oh, okay. ORD.
Oh, yeah. ORD of the character that you are given.
Awesome. Okay. So ASCII of D and uh,
Yeah. So
so
do
so
you remember how we discussed the approach?
yeah,
So
we need to find
we
the difference, right?
yeah. I mean we have to treat the first character first, and then we treat the rest in the differences.
Right, right, right.
Yeah. And then we can do exactly that
The
here.
the first character is first, and the rest we find the differences. Right.
Exactly.
Okay.
Exactly. Yeah. Let's do that. Yeah. Exactly.
Uh, okay. Uh, Let me just do it how we talked about it. So the first character, so ASCII D is ordinal D, and if I equal to 0, um, maybe I'll store all this in a temporary array. So temp dot append. So this would be the first thing. So I just add that directly. Uh, if else, then you only need the difference, which would be the last element of temp minus one, right?
Yeah.
So yeah, so this one it would first put 100 and then you're putting like 10, like 110 would be the ASCII value, 110 minus uh temp of minus 1, which is last element, 100,
Yeah.
110. But you need to find hold on, you need to find the other differences, right? 110, 111 minus 110. So this wouldn't work. It's so this ASCII D for the third element would be 111. Uh, and then I need minus 110. So how about this? I uh, store the ASCII value as well as uh, let me think. There's a simpler way.
Yeah. I think is you are maybe. Well, I know you looking like you want to do two things at a time, but
Right, right, right.
I would do one thing at a time. You extract exactly what you discussed. The first step, extract your ASCII value. Second step will be take the difference. I
Got it,
think
got it,
that will
got it.
make your
Yep.
life a lot easier if you do
Yeah,
that
yeah, yeah.
because you for time complexity you got a big O n anyway. It's gonna improve a lot.
Yeah. So first, just convert into ASCII.
Yeah.
Uh, and now you iterate through this temp array, and if I not equal to 0, temp, sorry, let's do range of length of temp. If I not equal to 0, then temp of I, you need to mutate these elements, equal to temp of I minus, no, do I need another? Uh, so what am I doing? The next thing is I need to find all the differences. Uh,
Yeah.
actually,
I
why
I
why complicate? I'll do one of the,
exactly. Yeah. Exactly. That's what I want to say. Don't make this difficult for yourself.
yeah. So if I equal to 0, then uh, temp 1 dot append equal to temp of I, else temp 1 dot append equal to temp of uh, I minus temp of I minus 1. Okay. Yeah, so if it's the first element, just append it. If it's the other elements, you find the difference between the current element and the previous element. So this looks okay. Now you have the now going back to so now it's to go to the step one, right? So what do we know from step one? Again, we can do for I in range of length of temp one. So if I equal to 0, uh, actually, yeah, let me do another temp 2. Maybe step 2 or something might be a better name. But temp 2 dot append temp 1 of I minus 1, right? Else temp 2 dot append of uh, get first value greater than 97. Sorry. Uh, so you need to pass temp 1 of I. Okay, so now it's a question of writing that particular function where I need to, you know, do this ASCII value. Maybe I'll write this recursively or something. So if ASCII is greater than or equal to 97, return ASCII, right? Else, uh, so I'm just instead of writing like a for loop, same thing, I'm doing it recursively.
Okay.
The base case is that ASCII is greater than or equal to 97. That means I found that value, right? As per our earlier assumption.
Yeah.
Uh, Otherwise, I just increment 26 and call this recursively. So it will keep on calling recursively until it hits the base case.
So
Uh,
one quick question for you is how do you know that this number at 927 that number is within the okay range? You're minusing something maybe below the range already.
oh, okay. Yeah, yeah, yeah. Uh, Wait. This is the first character, right? Now, the first character you will be adding plus one, right? Always.
Mm,
So when you are trying to revert it, decrypt it back, yeah, if you are trying to decrypt it back, you need to subtract minus one, right? So let's say if this is A, first character is A, that would be 97, and the decrypted message, the decrypted ASCII value would be sorry, the encrypted ASCII value would be 98, right? So
yeah, okay,
98
yeah,
minus one.
yeah, yeah, yeah. You got me. Yeah, you're right. Because when I wrote it, I also checked the first number, but I think it's redundant.
Sorry, what is redundant?
Yeah, because I think you're right. Because the first number is always between the range, so we are okay. I think
Yeah,
because
yeah, yeah. So the
when I
first
wrote the
number,
yeah when I wrote the code, I also checked the first one. I think that checking for the first one may be redundant for me. But that's how I did it though. But you're right. You don't need to check if that's the case. Yeah, you're right.
okay, so now the last step is to uh,
Convert it
hold
back.
on. So what is put it back, and I think that's CHR, right? That is the word. Is that the
Yeah, CHR. Yeah, exactly.
okay? Uh, so let me think. So again, for I in temp2 output plus equal to chr of I, and I return output. Does this look correct?
Um, yes, I think that should work. I think. I mean, logically, it looks okay. Um, I
Right.
don't see any bugs so far, and
We can try to quickly run it and see. I mean, if there is bug, we can probably, probably do it offline. Uh, there are multiple steps, so it's possible that there is some bug somewhere. Okay, no bug. Okay, nice. Passed.
high five.
Thank you.
Virtual high five. That's good job. Very good.
Yeah,
So
I
maybe I
I
can
don't
give you
think I
some.
could have done without the hints though. But yeah, I'll go with the time complexity. We have everything
Yeah.
as uh, actually. Okay, this for loop is order of n space, order of n time. The for loop from line 12 to line 15, and the for loop from line 17 to line 22 is also order of n time and space. This
Correct.
one is a bit tricky. So you're incrementing it, uh, but I think it's like constant.
Yeah.
It's not like
Exactly.
varies with the length of the input. So it's order of in time and space overall. And I think like even there must be a smart formula to not keep on incrementing 26. Some
Well, even the official solution involve that this keep incrementing. They use a while loop and then you use recursion.
hmm,
Well, I think maybe in this case, well, I don't think there's any advantage on one or the other. Honestly,
yeah, it's
uh,
constant anyway. So I mean
yeah,
you can get a minor optimization, that's all.
yeah. Maybe I can give you some feedback. Maybe because I like. Do you want some feedback from me though?
Uh Actually, yeah, once you finish this feedback, I'll give you the other feedback.
Yeah. Okay. At this point, I don't have any other follow up question. You code it up. It's logical. The code runs okay, which is perfectly pass all the test cases, and it looks good. So I have some feedback I for you is first thing and before anything you have done a good job, and this problem is not easy. I asked a lot of people and cannot get to that stage. You can code it up and then running all the test cases. But some nitpicking thing that I still want to improve your coding skill. One thing is the naming convention. So the temp looks like something I this is something I used before, and I get criticized by other interviewer, and they said, "Oh, temp, what's the meaning of temp? Are you gonna throw away that? You're not gonna use it anymore?" And then the temp to some people is not very descriptive,
Right.
and
Yeah, yeah.
so that's one thing. And second
Actually,
thing is
I thought I'll be using only one temp. Even in that case, maybe I can probably make a case saying, "Hey, that's just a temporary." But I ended up using temp one, temp two. So yeah, I agree.
yeah, I saw what you're doing. You try to do two things at a time.
Right, right,
But
right.
in a real interview setting, I would probably play on like a safe side that because down the road it's gonna be big O n anyway.
Right,
So
right,
either big O one n or big O two ends. Big O two n. I mean big O one n maybe I shooting the foot just right. I mean for myself,
right.
but But I do like your approach where you want to impress the interviewer. Maybe you can discuss the optimization at the end. You say, oh, if I'm given more time, this is how I will improve it. Okay,
Right.
but at least you have the code is working for you at the minimum. That you, and then I know that you are thinking of optimization, and now you're just under the pressure of the time or the nervousness that you maybe in this case you want to do a bit more. So that's something I would play on the safe side. So the one thing. Second thing is about the convention that you're following. So um, this one is the underscore, and this one is a camel convention.
Got it.
So
Yeah.
yeah, both of them might be completely valid. It depends on your style. And I'm a huge fan of camel case because it's so much shorter than the underscoring. But underscoring is mostly I think for Python convention because they have like a dendro line, like double underscore thing. Maybe it's more under your game. But I will stick with one. Because JavaScript is more like if you go to React, it's more a camel convention. But I will stick with one system, not switching during. Uh, and yeah, so this is the feedback I have for you. And this question certainly is not easy one. I asked a lot of people, and a lot of them cannot solve this problem. But once again, you have done a really good job, and you coded up and it works.
Yeah. Thank you for the hints. I think that worked. Actually, I still haven't gotten the intuition uh, behind those differences. So I need to look up the program problem again and get those intuitions. Yeah. So I think we can move to your feedback. So for
Yeah,
pancake sort, I think you figured it out. The only hint um, that I had to give was that max element and the element. I don't think I even gave the max element. I just told you. Sorry, I have a bad cough. Yeah. So I just told you that the element has to be in the correct position, and you figured it out. So that's great. I think you initially said min, but then when
yeah.
I told you that when you flip it, the array gets scrambled. So you got the hint, and then you said, "I'll do the max." So that was great. Uh, so I think that was the key though, figuring out the max element and then
Exactly.
knowing that you need to flip that two times to get the max to the current position. Um, that was good. One thing I might have liked is to get to the code a bit more faster. Uh, I think it was around 25 minutes. Yeah, maybe around 22 minutes when you got to the code. Uh, so that could have been a bit more faster. Maybe try to get to the code at around 15 minutes or at least, yeah, like be cautious after, especially since you figured the algorithm way earlier. Uh, I think the time was spent on running some dry runs. You ran multiple dry runs before coding, so
Yeah,
maybe you could have shortened that.
yeah. I
Like
did
after
it up.
one dry run, and I thought like after one dry run, you actually got the hang of it. So the second dry run was not giving any useful information.
Mm,
So
yeah,
after first dry run, you solved the problem. So then what's the need for the second dry run, right? Like you could anyway, you might have to do the dry run at the end of the program anyway, to validate the correctness of the program. Uh, so the first dry run was to just validate the correctness of your algorithm. Uh, so yeah, like after one dry run, like as soon as you got the solution, unless you are not totally confident, uh,
exactly. I wasn't too confident. That's why. I
Yeah,
tried it. I think, yeah, yeah, exactly. But I don't think it's necessary as you mentioned because I got a confirmation from you already. You're saying, oh, that's maybe the way to go. So I probably
yeah,
shouldn't waste time on the second dry run.
yeah. Maybe think why you weren't confident, right? Like you sorted the array. So what was the reason you were not confident?
That looks,
Because any more dry
yeah,
run is going to do the same thing.
yeah, okay, yeah. It's not gonna be any value added. Yeah,
Whether you sort first three elements or the whole array is still the same, right? Um, I think what got confused you is like the last three elements you were able to sort it, but the remaining three are like already in the sorted position.
yeah,
So
yeah,
you are like, will that work? But by induction, it should work, right? If the last three elements work, then the first three also should work. You
exactly.
are only doing the same step again and again.
I afraid that I got lucky.
Oh, yeah, yeah,
Yeah,
yeah. Especially for sorting, I think by induction, if you just validate for two elements, should work for the remaining all elements. Uh, so that's one thing. Uh, the implementation could have been bit more cleaner. I think there were some one-off cases, like that K plus one and then K. Uh, Maybe like one thing I would probably think of is uh, I think it was good that you tried to utilize most of the built-in functions in Python, but for this problem, it might have been just simpler to not use those built-in functions. Uh, so instead of the doing that flip, you could have just written a for loop for 0 to k and just do the flip. So you would not have come with that issue of that first and the rest, and then figuring out, hey, what happens if the rest is goes out of index. Like all that matters is you are flipping the first k elements, right? The rest doesn't matter at all. So yeah, you could have probably just done the basic for loop flipping.
yeah. Maybe I
Uh,
would use like a two pointers and then keep swapping.
yeah, just two pointers. It's just a reversing. It's a string reverse
Exactly.
basically.
Yeah, yeah,
Uh,
exactly.
that one and that again the other one for the max and the index of, you could have done like a find max function and that function returns the max index alone, right? You don't really care about the max value. You only care about the max index. Uh, so you don't have to do that max of that function. So
Oh yes, yeah. I don't need the number, the maximum number actually.
yeah, yeah. So you could have just written a function like find max, and that function again a basic for loop where you actually find compute the max in that for loop, and when you update the max, you find the max index and return the max index. That might have been
Exactly. Yeah.
simpler, and it would have avoided that issue where like what would happen where you're using the index of, right? It probably would not work correctly if you have
Yeah.
duplicate values.
That index of function has a lot of bad reputation actually. Uh, yeah, people hate using it because sometimes the value does not exist. Sometimes there are a duplicate number versus which max index is returning. So
Yeah,
yeah, that was not very well thought, I must say. Yeah, I
yeah.
basically shooting my foot, which
Yeah,
is not good.
though like the one plus point is like you knew that built-in function, but I don't think in this context that is actually necessary, or that's probably not what people are looking for in this interview. That you are knowing all these functions in Python. Uh, yeah, I think those were the two major callouts. I would think. Yeah, yeah. The and because you did the most of the dry run in the beginning, you didn't have time to do the dry run to validate the correctness of the program.
Yeah,
I
yeah,
think if you had split the time to do the dry run correctly, like one to validate the correctness of the algorithm and the second dry run to validate the program, you might have actually found those mistakes on your own. I think you kind
yeah,
of rushed through the dry run while validating the correctness of the program, um,
Exactly.
which
Exactly.
is probably more important if
Exactly.
you
Yeah.
compare. Yeah. Uh, yeah, I think that's all the feedback I had. You apart from that, like everything was good.
Yeah.
Um,
The,
the
the
approach was
second job
correct.
one.
The time
Yeah. The second
complexity
job
was
one.
spot on.
Yeah. The second job one kind of suck away my time. That I should have used that time for the last dry run. Yeah. You're right.
Yeah. Uh, yeah, actually, that's all I had.
Okay. And thank you so much for your feedback. That's very helpful. And I'm not sure if you have a spare few minutes to network. It's optional right now. If you don't have time, it's fine.
So yeah, we could actually. I did enjoy interviewing with you. Um, so are you doing multiple mock interviews now?
Yeah. I've been doing prom for quite a while actually. I've interviewed like maybe like 40 or 50 people.
Wow.
Um,
Okay.
I've been on here for maybe a long time. Maybe I can share my LinkedIn and then we can get connected.
Yeah. So if you are doing mock interviews, rather than waiting for prime to match, like we could also, you know, schedule time or calendar and match ourselves. What do you think?
Yeah,
Like Pramp has
definitely.
an option to match with a friend as well, right? So we could try to do that.
Yeah, and do you have any upcoming interview for you?
No, I'm planning to.
Oh, so you're just
Uh,
preparing.
yeah, yeah. So I clicked follow. That's the way, right? Or is follow not
Oh
the
no, no,
right word?
you can connect with me, friend me, send me a what?
To connect. Okay. Yeah. I haven't used LinkedIn for a while.
Yeah.
Yeah, I
I
just
don't
sent you an
see.
invite.
Okay, let me see. Uh, I haven't seen yet.
Vivek
Yeah, I'm waiting.
says it's pending
Oh yeah,
from
yeah.
my
Okay,
end.
I'm seeing you now. Okay, perfect. Vivek. Yeah, perfect.
Yeah.
Oh, you are at Amazon. Gee,
Yeah.
wow, that's impressive. Wow,
Okay.
that's awesome.
Yeah.
Yeah.
It's
So
not
which
a, it's not, it's okay. I mean, it's all a matter of cracking interviews, which if you keep trying, you'll also do.
which I mean now you are already in Frank, but which company are you actually aiming for then? You're a senior developer. Wow.
Um, yeah, I'm actually testing my market value, to be frank. I mean, I it's been a while. I've been in 4 years in Amazon, so I just thought to interview and see what. Like, I know Facebook and Google pay at least 10 to 20% better than Amazon.
Oh
Uh,
yeah, Facebook is yeah.
though, yeah, with Amazon stock is actually much better than the other companies, at least for the past 4 years. If you look at Amazon stock, it's better than Google or Facebook. So it kind of levels out, uh,
I hear you. I hear you. Yeah, yeah.
but
Okay.
in terms of benefits, Facebook, Google is better. So I'll try that.
Yeah,
I'll also
maybe I
try
can.
other companies.
Maybe speaking of Google, maybe I can share with you my experience with Google. So I actually interviewed them like 2 months ago. Uh, I passed the first round, but I didn't pass the second round. So because I got asked a question about coding a Python iterator object, and then
Okay.
I get completely stuck. I didn't know what it was iterator, and because for most of the data structure algorithm, sometimes I overlooked the importance of object coding or object design.
Hmm.
But looks like those object design problem is very meaningful for the interviewer. For some people really like them.
Right.
If I got asked for like a DFS or like a matrix, like a finding a maze or like a dynamic programming problem, probably I would be a lot better than that. But
Yeah.
I
Yeah,
was
I have
pretty
come
bombed.
across this question before. I think you need to write like an iterator class and uh, hold some state, what the current pointer is, and all that, right? Uh,
Yeah,
I don't know. Yeah, it's tricky,
yeah.
and you need to switch your brain from this data structure algorithm to like object oriented approach. It's mostly a matter of holding state. I think. I don't think it's doing much. Iterator what it has like next method or previous method. So you just need a pointer to that underlying data structure. Uh,
Well, I was asked to code the next function next.
yeah. Um,
It
I
was
think you need to get the association right between the data structure and the iterator or class instances. Uh, yeah, it's
yeah.
fine.
Well, I get bombed by Google, so I was banned from going back for them like at least like, for 1 year because I didn't do I did it very badly. And but that's me. I'm keep sharing my story to my friends, also the friends on prem. Don't learn by my mistake the hard way. Learn it before you go to the interview. That's why I'm keep sharing my experience, my failure to my friends
Actually, I
because
have failed in Google too. So before Amazon, I failed in
okay,
Google.
what trip you off?
Sorry.
What tripped you off? What failed to you?
Yeah, actually, I don't think I was that well prepared. So I think I did a mistake. Mm, I was working on a different company, Qualcomm, for 4 years, and the first interview after 4 years that I did was in Google. I should have probably done the reverse way. Um, so I had not much experience. I didn't even do much mock interviews. So I went the Google was my first interview in a long time.
Ah, yeah, same
Uh,
as me. Yeah,
so that was a wrong approach. I should have maybe started with the like easier or companies that I didn't really care, and
exactly.
then worked my way through. But I did the totally the opposite way. So I bombed. All of these were on site. I was able to do the phone screen well, but on site I didn't do well. Uh, Google, Facebook, LinkedIn, and I think the fourth company was Amazon. And by the fourth company, I was pretty confident. So Amazon, I did very
Yeah,
well.
yeah, that's what I figured. Yeah, yeah. So
So
I think
this
you
time
should try
I'll
more.
not repeat it. This time all these dream companies will be at the last, and all the other companies I'll do it in the beginning.
And I
I
would
mean,
suggest
again,
you.
it completely boils down to luck. So there's always an
Yeah,
element of luck. Uh,
I
that
agree. Yeah,
don't think too much about it.
yeah. I would suggest you. I mean, now you have experience. I think you can get any interview you want, even in the market right now. I would suggest you that you try as many prom guy as you can. Like I mean, we are. I mean, I'm the prom guy that you. I'm here help you to improve your interview, and then you try enough prom guy. You go to the company that you don't really care, and then you go to the one that you do care. That's all what I would do if I was
Yeah,
you.
but Pram doesn't seem to have these kind of questions, right? I think that's the problem with relying on Pram, like the iterator question.
Oh yeah, there's no object design. That's exactly. That's only on leak code or some people talking.
I
On a
don't even know
discussion
if it's
board.
there in lead code. Is it there on lead code?
Yeah, there's one on LeetCode. It's very non-popular problem.
Got it. Hmm. Yeah, it is non-popular.
Yeah,
Uh,
I must say I it's not very lucky. I'm not very lucky. Yeah, this one. Yeah, I'm not sure if Google is under your radar. If it is, yeah, I would suggest you to try this out. Um,
yeah, Google is definitely in my radar.
okay, yeah, I would suggest you to. I heard that Google has a pretty good work-life balance compared to Facebook. Um, but yeah,
Yeah,
if it
I
is,
mean,
I suggest.
work-life balance is so maybe as a company, it also depends on the team. Like people say, Amazon work-life balance is very bad, but in
Yeah,
my
that's
team,
why.
it has been pretty good. So there is a lot dependent on your team and manager.
What do you mind me what exactly what area of a business or product you're working on in
I'm in
Amazon?
music, Amazon Music.
Oh, Amazon Music. Okay.
Yeah, it's pretty chill. Like the whole org, except maybe few teams, like the whole org is pretty chill. You go to, yeah, it really depends on the team and all that. And sometimes some teams are tough, but you might end up liking them also because you learn a lot.
Yeah, I almost get an
Now,
interview with
now the
DW.
reason why I'm trying to switch is because I'm becoming too comfortable. So I'm planning to even switch
Ah,
internally because yeah, it's very lazy. Like especially with work from home thing and all that. Uh, it's been more lazy. So
so you're
uh,
allowed to work from home forever in Amazon?
not yet. They haven't defined the policy yet. It's
Okay.
going to be a hybrid for some time.
Okay, that's very good actually. But yeah, if you want to learn more and see more, and then yeah, lead code, you have to probably the first gate you have to go through. But given that I am seeing your success or your work history, I have seen no problem with you getting a lot of interviews. Actually, I'm very impressed based on your experience.
Yeah, it just means I'm old. Okay,
Mm, well, you're okay, I think.
that's fine.
Yeah.
I don't care.
So yeah, I'm not sure if I'm. If, do you mind me if I want to get an interview at Amazon? Maybe can I ask you for a reference or referral?
Yeah, yeah,
Okay, yeah, I'll come back to you if I need it. And
yeah.
um,
You just ping me the job ID and I can refer you.
perfect. Yeah, I appreciate that. And meanwhile, if you see me as a helpful for you for preparing for interview, yeah, feel free to like come back to me and then we can sit down and then have a prompt session again.
Yeah, we can connect.
Yeah, and then just drop me a message. Let me know the time works for you, and then if that time works for me as well, and then we can sit down. And given both you and I working from home right now, we have a lot of flexibility, so we can use the prompt. I mean, we can go to leak code even. I can search one leak code problem for you, and then we can. I just did one with the guy from Huawei yesterday, and he was going for tutor today, and he just came back to me and say, "Oh, you're so helpful, and can you help me out?" And I was like, "Yeah, I can help you out." So yesterday, and then today he went to interview for tutor. I haven't checked with the guy yet. So if you also want to do something like that, try me, and then yeah, you try on me better than try on Google or Facebook. And I'm here to help out the people and all of my
Yeah,
friends.
yeah. Thank you so much. Yeah,
Okay.
same here. Reach out to me whenever I'm free. We
Yeah, I
can
probably will come
work
back
on.
to you because I haven't have a lot of experience with interview with a real Amazon engineer. So
Sure,
yeah, I will come back to you if I will definitely come back to you actually,
no
and
problem.
then check
Yeah,
in to see if you have time, and then we can sit down again.
sure. All right.
Okay,
See ya.
and by the way, last question for you: do you have any particular target company in your mind so I can maybe find specific that company's question to ask you next time? What's your dream
Uh,
company actually?
my top three that I want to get into are Google, Facebook, Netflix.
Okay, Google, Facebook, and Netflix. Okay,
Netflix,
maybe I.
the order is Netflix, Google, and Facebook.
Yeah, Netflix is really well paid. I know they only hire seniors, and they hire like $500,000. I know
I think
Netflix is
it's
really
way too hard, way too competitive, but that's like the dream. So,
so the order of your preference. First one is Netflix, second one is Google, right? Or third one is Facebook, right?
right.
Okay, maybe next time when I come across you, I will prepare a question specifically in the order for your preference.
Yeah, yeah, sure, sure. Yeah, I don't want to spend too much of your time too, so just take it lightly.
Sounds
And
good.
I mean, hopefully it's useful for you as well.
Yeah, because I have to solve it first before I come to you, so it's gonna be good use of my time. Don't worry about this.
Yeah, yeah. Okay.
Okay,
All
see you
right.
next time.
See you. Bye.
Have a good night. Bye bye.
Bye.